Aneco. All good? Everybody can see my screen? It's working good. So Aneco, is why I'm here presenting today, is really as my role as a project manager for Aneco. So Aneco is this association founded in December of 2020, and there's three main action points. It really installs decentralized treatment plants in Switzerland. There's also the research and development of these different types of very natural systems, treatment systems that we implement. And then there's the aspect of awareness raising and lobbying. And this is a lot through our activities within VALU, which was said before is kind of the sister association here in Switzerland promoting decentralized sanitations. And why does aneco do all these things? Our main goals and values are really to reduce the impact on the environment and aquatic systems, to close the cycles, water, nutrients locally, to contribute to local agriculture by compost, mineralized fertilizers, and to save energy. So this is really the base of aneco. Today, though, I will be mostly presenting the projects done by Equilibre, as there's three buildings made by Equilibre. It's a housing cooperative, eco-responsible here in Geneva. And it's the three first buildings, really apartment buildings, that have implemented decentralized natural wastewater treatment systems in their plan. To know that these buildings were all built earlier, before Aneco existed, and since Aneco was founded in December of 2020, Aneco is now also responsible and has taken over managing these systems, doing any type of changes, moderations to them that we will get into as I show. So today I will go through Cressy, which is the building, the first Equilibre building that was built in 2011. At Cressy, there is two different types of treatment. There's the dry composting toilets, and then for all the gray water, there is a planted filter. As we're talking more about toilets today, I will focus on the toilet part, not the filtered plant, the planted filter. There's a system at Suberin, which is a vermifiltration of both the black water and the gray water. And then there is Les Vergers, which was built in 2018 and has experimented pilot projects with two different systems, one being the Cacaroussel, a dry toilet that is just within the apartment home, and then the Pitribon, which is the treatment of the urine that is separated. So to begin, Cressy, as I just said, is a composting toilet. So here on the up in the upper right hand corner, we see the composters. These are three different composters, which are located in the basement of the building. These composters are connected to the Berger Biotechnik toilet, which is a German toilet. And since 2021, these toilets are also were equipped with the Separette, a type of toilet seat, which allows the urine to be separated. This was done because of some smelling odors that was coming off of the ventilation on the rooftop and bothering the neighbors. And so it was decided to separate the urine. Here to the bottom right, we see a schema of the composter. So we see the ventilation, which is a passive ventilation coming from the toilet to the rooftop. We also see the three different compartments of the waste. The first compartment, which is really the fresh fecal matter. In the beginning, it was both fecal matter and urine and toilet paper and everything else that goes into a toilet. The second part is the volume once it's a bit degraded, but it really stays in the first and second part during the first year of composting. And the third compartment is after 1 year, they will pull the compost from compartment 2, bring it to this third compartment, introduce earthworms to continue the composting process, and then let it sit for 1 more year before they take it out into the yard. So the architectural constraints of such a system is really that in order to have this dry toilet in a building of 3 stories, with dry toilets, you really have to have a vertical descent. So it takes a lot of space. Each toilet, you can imagine just a vertical column in each apartment. So the people on the first floor have the chutes of toilets from the second and the third floor that take up space within their bathroom. So this is a spatial constraint that was okay for 3 stories, but would not be okay for any building more than 3 stories. The overall space required, so it's 3 square meters surface area in the basement. This is like the active surface area, but then there's also 7 square meters is the SIA norm, so the total used area, because you also have to leave space to come in and empty the composter as well. Another architectural constraint, or just constraint, is that in this compost, because of urine, because of watering, there will be liquid that will also lixiviate out, and this liquid needs to be evacuated. For the first, from 2011 until 2019 at Cressy, it was just evacuated into the sewer system. But then in 2019, this liquid was then treated on a charcoal filter, similar to the Pitribon, which I will discuss a bit later. Also the sizes and volumes. So the composter has a width of between 65 to 75 square centimeters. And this width really depends on the size, the household size, and the apartment size. So it can treat from 1 to 6 people. And yeah, the volume is 1 to 1.3 cubic meters with about 300 liters of compost per person is the volume necessary. So a bit also about what's the maintenance of such a system. So the habitants of Cressy, each habitant is responsible for their composter, and 2 times per month they go down into the basement just to check on how is the composter going. Is it going well? They have to see if it's humid enough, if the compost has a nice humidity. If it's not, they must add water. If it's too humid, they add straw. If there are flies, they can add leaves from the garden, which was a big, how to say, a breakthrough, a big finding that they had, because at the beginning they had a lot of problems, not the beginning, but maybe 1 year after, they had many problems with flies. And they tried many different solutions, and the solution that worked the best was introducing flies from the yard, or leaves from the yard, as the leaves contain spiders and many other insects, which are natural predators of the fruit flies. And so if any flies are present, they can just add more leaves. If they see the earthworm population is not so high, they can add more worms, and they can have to clean the air filter if it's blocked. And then once per year, they have to empty the compost. Here on the right, there's a schema of kind of this mass balance. So for a family of 4 people, there's estimation of 2,800 liters that arrive per year. After the first composting part in the back side, the first year of composting, 1,600 liters is evaporated, 400 liters is lixiviated out in the liquid, and then only 800 liters of like solid mass is left. Then after 1 more year of composting, once they pull it into the third compartment, the frontal compartment with the earthworms, here another 680 liters is evaporated out. And in the end, about 120 liters needs to be removed per year. This is then removed, which they estimate is 2 to 3 hours of work, and then left into their outdoor composting place for 6 months to 1 year before they use it in their vegetable garden. So that's for the composting toilet at Cressy, and now we can move on to the vermifiltration system, which is at Suberan. So Suberan is the second building built by Equilibre, and this building was much bigger, 38 apartments, 100 people, and 7 stories. 6 or 7, I think 7 though. 7 stories, and so with this system, with this size, it wasn't possible to redo the composting toilets. They had to think of a different technology, a different way of treating the water, and they the Equilibre bureau, the people, they searched for many different solutions, and they finally found Philippe Moyer-Genoux, who's a biologist from Switzerland, who talked to them about this vermifiltration system, and this is what they ended up installing. So here's a schema. It's quite hard to maybe understand, but we can walk through it. So the toilet that's used is a Watsman EcoFlush. And why are the two separated? It's not actually the black water and the urine is not treated separately. It's remixed, but the reason for separating the two at the toilet was really to have a very low flush volume. So with this toilet, there's a 0.5 liter small flush and a 2.5 liter big flush. And this was really important to not have too much water that's arriving onto the filter system, because the earthworms, we do not want to drown them in too much water. So the system starts there with the toilets. The black water then, after remixing, is found into a intermediate tank where there's a pumping station, and it's a shredding pump that will shred this content onto the vermifilter. The vermifilter for the black water is 44 square meters, so it's very large, and it's located in a treatment pit that's in the yard at Suberrin. I will go just quickly into the gray water because it's just so you know what happens to the gray water, though we're focusing mostly on toilets today. So the gray water is also treated by a similar system, a vermifilter system, though it is degreased first. It arrives via gravity into the treatment pits. And then from the degreaser, there's a part that's pumped from the bottom. Everything that sediments out of the degreaser is pumped onto a vermifilter, which is much smaller than the black water. Pardon? Sorry. Yeah, so it's pumped onto the sediments from the degreaser is pumped onto a smaller vermifilter, 6.5 square meters, much smaller than the 44 square meters for the black water. And then the clarified gray water is just treated on charcoal here. All of the water is then mixed and treated by two separate mineral filters. So what are the architectural constraints of such a system? All right, here I have another schema just that shows it a bit more nicely. The architectural constraints are that there's additional canalization needed. So there's two different canalization coming out. There's the black water from the toilets and the gray water from the rest. And there's also two canalizations going in, because this water is then reused for flushing and for watering. The treated water is used for flushing the toilets and watering the garden. So you have the drinking water and the treated water going into the building. It also needs a large amount of surface. So in this case, it's 80 square meters by 3 meters deep is the treatment pit. And this can be either outside or in the basement, depending on what is available for the different sites. Here at Suberrin, they put it in the outside area as there was space. Just to give an idea about the sizes, so here was dimensions for 0.45 square meters per person equivalent. That was for just the vermifilter part. And then for the secondary treatment, the mineral filters, there's the first one is 50 cubic meters and the second one is 55 cubic meters. So we're talking quite large volumes here. So it takes quite a bit of space. Some implications for the habitants. So they have to use ecological and biodegradable cleaning products and hygiene products, as it's a really natural system. The urinating needs to be done while seated in order for the separation to work accordingly. And also they need to clean the toilet in a way, because there can be struvite accumulation due to the very little flush water. And so yeah, this is always adding citric acid or vinegar helps to avoid struvite accumulation. The advantages are that it decreases the drinking water, potable water consumption. So at Suberrin, they consume 55 liters per person per day of potable water, which is in comparison to the 140 liters per person per day for the average Swiss person. And also they have compost for the vegetable garden. The maintenance of the system is actually quite low. The only thing they must do, well, they have to check on the system quite frequently, maybe once per week, once every 2 weeks, just to verify that things are going well. This can be done with smelling, by looking, things look all right. And once we see that it's accumulating, that there's quite a lot of fresh material, every 2 to 6 weeks, you have to alternate which side of the large black water vermifilter is being used. So only half of the filter is given the water at a time, and then they add straw at the same time. This isn't necessary during summer, though it's done just for a visual aspect, and during winter it's important to maintain some warmth because it's located outside and it's quite cold here in winter. So finally, getting to the third building, the most recently built building is Les Vergers. These are 3 buildings actually, also in the canton of Geneva, 67 apartments in total. And the challenge of this project was that there was no outdoor space as there is at Suberhan, so they could not imagine implementing such a system outside. And also the buildings are 6 stories high, so they could not imagine something like Crécy. So they had to be innovative, and that's where they decided to test 2 different systems, one being the cacaroussel, which is this dry toilet that's located really in the bathroom, and then the pitribon, which is a treatment of urine in order to make a fertilizer out of it. They started small, so only 4 households had the cacaroussel and 5 households were connected to the pitribon production. The cacaroussel, so here's some images of it to the right. It's a toilet that never needs to be emptied because there's earthworms within this composter that will degrade all of the matter, the fecal matter and the toilet paper into oxygen, CO2, and into water, which will then just come out. The advantages of such a system is that it really has minimal architectural constraints. It just has the same constraints as any standard toilet, so it needs some space and it needs ventilation, but it really can even be, it can replace a normal toilet in any apartment building, any existing apartment building. One constraint is the urine, so it separates the urine from, it does not treat urine. So the urine has to be either connected to the wastewater treatment plant, like it connected to the already existing sewage, or it can be treated in situ with pitribon, for example, or any other urine treatment system. The sizes, so the actual size can vary depending on the bathroom space, but it's the minimal is 86 by 86 centimeters because you really have to have this internal drum that has a minimum space for turning. I will explain a bit more how it works on the next slide. The height is 50 centimeters and the amount of compost is between 25 and 50 liters of compost per person, which is much less than Crécy. At Crécy, it was 300. This is mostly, thankfully, due to the separation of urine, which wasn't imagined in the original case at Crécy. And I think now if we had to reimagine the composter at Crécy with the urine separated, we could also imagine a system much smaller than what was implemented. So the maintenance and the challenges is that, so once per week, when using the cacaroussel, you have to turn the inner drum. So you arrive, you will dig a hole, and during 1 week, you will do your business in this hole. After 1 week, the family will turn the drum 1/8 of a turn. They will dig a new hole, cover up the business from the previous week, and continue. This will continue for 8 weeks, and by the time 8 weeks is over and we come back to the spot where we originally started, there will be nothing left besides just nice soil, nice compost. Another thing that must be done weekly is to verify the humidity. Depending on the ventilation of the bathroom and the warmth, the heat of the bathroom, it can get very dry. And so we might be necessary to water the compost to make sure that it stays humid enough for the earthworms to do their job. And also if you water too much, there could be excess water that will then accumulate in the plate at the bottom of the compost, and this should be emptied if you see anything. Last thing is just to verify the urine canalization to ensure that it doesn't have this struvite accumulation and to clean it with vinegar if necessary. And then twice per year, they have to lixiviate the compost, because actually what happens during this composting process is that most things will be evaporated. Most of the organic material is turned into CO2. And what's left is the mineral salts. And this mineral salts, if not lixiviated, will create a toxic environment for the earthworms. It will get too salty. And so once every 6 months, it's good to just use a lot of water to lixiviate out these mineral salts. And this water is actually really good as a fertilizer. So the water that's used, this lixiviates, can be used then for watering your household plants. The biggest challenge, though, with this system is the fruit flies, which there has been a lot of flies and has caused, some problems. We spend a lot of time trying to find solutions to avoiding fruit flies, and there's a few different natural products that we have discovered that if anybody wants information on, I can provide. So the Pitribon is the second system implemented at Au Verger. This system uses the Laupen Save separative toilets, and it treats the urine on a geotextile bag that has filled with charcoal. And the main objective of this charcoal is to serve as a substrate for that bacteria can then grow, and it's the bacteria that will then nitrify the ammonium and into a stabilized state nitrate, which can be used as a fertilizer. On the bottom here, we have some images of the different types of Pitribon that we have. The maintenance for such a system, so it doesn't require too much maintenance, just regular cleaning of the toilet, again with citric acid or vinegar for the struvite formation. The sizes needed, so the main goal is to really arrive to a 48-hour hydraulic retention time. This is because the process of nitrification takes time, and also to start degrading micropollutants and things like this. So we really aim for 48 hours retention time. And this, depending on how much urine is coming in, it can be 20 liters of charcoal per person for dry toilets, or 30 liters of charcoal per person for flush toilets. Its dimension, the size is 35 by 35 by 170 centimeters. So it's actually quite small. It doesn't take up too much space, and this type of bag is for 5 people typically, given the amount of charcoal that can be put into it. The architectural constraints, so the space needed. Here it's written 8 square meters per 20 people, though we're doing some tests and research in order to really optimize the system. There's the additional canalization for urine. There's a good ventilation, which must be put in place, 1 renewal per hour. And then we also have to think of the space for the retention tank of the fertilizer, and accessibility of the fertilizer to the garden, for example, or how to then make the fertilizer usable. So I'm getting to the end. But one thing I wanted to state is that these systems are in constant evolution. So, for example, Crécy, there was this long battle with fruit flies, which I mentioned before, and the final solution found was to add the leaves from the yard. There was also this odors from the ventilation, which caused us to separate the urine, and so the composters now only treat the brown water, the fecal matter. It's not really water, the fecal matter, and not the urine. And also at Suberhan, the system has changed quite a bit since it was first inaugurated in 2017. The way that the gray water was distributed was changed. The wood chips that were originally in the vermi filter were replaced with charcoal. This was then done also for the black water filters. There was a degreaser that wasn't originally in place that was implemented. And there's even more further changes, which will happen in 2023. So it's really pilot projects that are in constant evolution and constant study. So that being said, we have some more projects. These are aneco projects now that are upcoming in the future. The 3 green circles are the 3 buildings of Equilibre that exist actually, and all of the blue circles are projects that will be built in the future. And then also on a Swiss level, we stay mostly in the French-speaking part of Switzerland, but we can also see the green again are already implemented projects, and then the blue are future projects which will be implemented. So it's continuing, and the types of projects really vary between urine treatment or vermifiltration and cacao cell. It's really the three main solutions that are implemented by aneco. So that's all from me. I don't know if you have any questions, how much time we have left.
Thank you very much, Kayla, for that very nice insights.